Yeah, Sachin.
All right. Okay. Vinay, can you hear me?
Yes, Sachin, I can hear you.
Okay. Okay. All right. So, Vinay, if somebody asked you whether ARP is a layer 2 protocol or a layer 3 protocol, means a data link layer protocol or a network layer protocol, what would be your answer and why?
Sachin, it comes under a data protocol and
comes under which layer?
Data link.
Okay. Why?
Because it is a layer 2 protocol and
Because it's
I didn't get to that.
I can't hear you. Nah. Speak a bit loud.
Yeah, Sachin.
Yeah, why it is a layer 2 protocol? I mean the data link layer protocol.
Data link layer protocol.
Why? Can you prove it?
No, Sachin.
No. Subhashri, what would be your answer?
Sachin. Because it resolves the MAC address. And
Because
MAC
it resolves the MAC
below.
address. Okay, but it resolves from IP to MAC, right?
Yes.
Okay. So can be considered as a layer 3 protocol also?
Maybe, but I'm not sure.
Okay, so what you consider it as a layer 2 protocol or layer 3 protocol?
ICMP.
No, I'm asking about ARP. Do you think it works on layer 2, that is data link, or do you think it works on layer 3, that is a network layer?
It works in data link layer.
So how can you prove it? You are saying that it resolves a MAC address, right?
Yes.
Okay. But what I am saying is, actually the definition of ARP is resolving IP address to MAC address. If it knows the IP address, what would be the relevant or corresponding MAC address it resolves, right? So it does involve IP and MAC both, but still it is considering a layer 2 protocol, not a layer 3 protocol. So I'm just asking the reason why it is considering to be a layer 2 protocol. How can you prove it? Ranoy?
Yes, Sachin.
Same question.
Data between nodes, that's why.
Hmm?
Because it transfers data between two nodes.
That is the reason it is considered a layer 2 protocol.
No.
Then what do you think? Shashank? Shashank, can you hear me?
Yes, Sachin.
Same question. Whether ARP is a layer 2 or layer 3 protocol?
It is a layer data link.
Okay. And how do you prove it? Or how can you say?
So it resolves the MAC, switching the MAC addresses to send the data.
Again, it is not the right answer.
Or it is both the layers. Is it layer 2 and layer 3 both?
No, it works on layer 2 only. Gurumurthy.
Yes, Sachin.
How do you say that ARP is a layer 2 protocol? How can you prove it that it's a layer 2 protocol?
Yes, I thought the answer as this. It resolves MAC addresses, and the data link layer is the one which involves around the MAC address.
Okay. But the thing
Yes.
is that it is not to the point answer, because it is resolving the MAC address, but from where it is resolving the MAC address? It is resolving the MAC address from IP to MAC. Does involve IP as well as MAC here. So we can consider layer 3 also, layer 3 protocol. But 100% sure ARP is a layer 2 protocol. Okay? Is a layer 2 protocol. What I need to know is, if somebody asks you, okay, you are saying layer 2 protocol, very correct answer. Then he will ask you, how do you say that it is a layer 2 protocol? Because it does involve IP and MAC both. But still we are considering it as a layer 2 protocol. Why? Or prove it. Gunashekar.
According to me, ARP stands for Address Resolution Protocol, and addresses comes into the picture only in networking layer. So that is where we need IP address, and resolution takes place in that layer. And even logical addressing is a part of networking layer. So I would say it comes under layer 3.
No,
Sachin,
again I would say it is not a layer 3, it is a layer 2 protocol.
Sachin, is it
In
because
OSI
the
layer,
ARP is embedded within the Ethernet frame, and Ethernet frame is from data link layer?
Correct. Okay. If somebody asks you, how do you prove it? Simply, you can challenge anyone. If he or she says it's a layer 3 protocol because it is resolving IP to MAC, or it is a data link layer because it is resolving IP to MAC. Correct. Data link layer. Network layer, no. Why? Because the thing is that it is encapsulated in an Ethernet header. Ethernet header will encapsulate, or Ethernet frame, I would say. Ethernet frame would encapsulate this ARP request. And that is a layer 2 thing. That is not a layer 3 thing. Okay. Just open the Wireshark, show him. Where is ARP encapsulated? Where is ARP coming? Let me share my screen.
but Sachin, in OSI, I mean TCP/IP model, it shows that it comes under networking layer, right? So
No.
why?
No, it doesn't. It will not. Where does it show?
No, actually, I had a subject from my third semester. In that, we had a TCP/IP OSI model. So in that, it comes under networking layer.
Maybe
Even
that was wrong, because the thing is that you can see here. Can you see my screen?
yes.
Where this ARP resolution is encapsulated under the Ethernet 2 frame. See,
And Ethernet comes under
right.
data link.
That comes under the data link. It's a layer 2 protocol. Okay. If I am saying ICMP, okay, let me open ICMP. Now, where ICMP is encapsulated? Under what?
Network layer.
Yeah, network layer means IP, internet IP header.
Yes.
IPv4 header. Okay. Normally we can say IP header. So under the IP header, we have ICMP encapsulated. So we can say it's a layer 3 protocol. Right. So very clear and concise answer if you give to the interviewer, right? He will not be able to cross questioning you anything more on this. Everybody, please keep in mind. Okay. Going further to the things, but leaving the things that you have already done will not be. Okay. Now, what we understood so far is the high level view of ARP and ICMP. Okay. Now we'll see how the ARP packet looks like. Okay. Till now, we know that ARP contains 4 things. Okay. That are pretty much familiar: source IP, destination IP, source MAC, and destination MAC, or target MAC. Whatever we want, we can say. Other than these 4 bits, we have something else also. Okay. You can see here. We see our packet. If we see our packet, this is our packet, right? Our request. We can see hardware, protocol type, hardware size, protocol size, opcode. What are these things? We are pretty much familiar about sender MAC, sender IP, target MAC, target IP. If I'm saying target means destination, you can say anything. But what are these fields all about? Hardware type, protocol type, hardware size, protocol size, opcode. You don't know, right? So hardware type is like which network we are running it onto. Okay, means we are running it on the Ethernet, right? So by default for Ethernet, the value should be 1. Protocol type. Protocol type means for which upper layer protocol I am running this ARP. Ultimately, ICMP is the one who requires layer 3 and layer 2 information, right? And that's the reason ARP would get triggered. So ARP would get triggered for what? For IPv4, that is IP protocol. Hardware size or hardware length, you would say. So what is hardware size or length? That is 6, nothing but the MAC address, 6 bytes. Protocol size, that is IP size, that is 4 bytes. And opcode means operation code. So operation code for request, it is 1. And for reply, it is what? 2.
Right?
Sorry?
2, right?
Correct. 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 So if we represent it in tabular form, you can just represent it how our packet looks like. See, why I'm telling you this, you need not to remember it, okay? You need not to remember it. And anyways, while supporting the customers, you have with you internet, okay? You can open up Google and you can see the ARP packet. That is not a problem. But you should be able to, if anybody asks you what this field all about, you can just say like this field is representing this field is representing this, right? For that purpose, we need to have. So what we can have as per the captures only, I can say hardware type, hardware type, protocol type, here I can make 3. Here we'll put hardware size, or we can say length. Here we can say protocol length. Here we can say operation. Okay. And next is, we know already from these many days we are doing it. Source MAC, destination MAC,
source IP,
and destination IP. Okay. So these 4 things we are pretty much aware about it. What we came to know now, we came to know about these 5 fields. Hardware type. Hardware type means on which network we are running. So that is Ethernet. Protocol type, for which protocol we are trying this operation. We are trying this operation for IP or IPv4, correctly if we write. Hardware size or length. Hardware size means MAC address size. MAC address size is 6 bytes. So 6. Protocol length, that is IP, this one. Okay. So that is 4 bytes. And operation, that represented by opcode, operation code. So if it is a request, ARP request, then opcode will be 1. If it is a reply, then opcode would be 2. That's it. Right? And that's what we are seeing here. Exactly same thing, correct? So now you know, whenever you anybody asks you like what is the hardware type in ARP packet or what is the protocol type in ARP packet, we can easily tell that. Ethernet, IPv4, hardware size means MAC size. Protocol size means IP size. And opcode means operation code, which operation is taking place, whether it's a request or whether it's a ARP reply. If it is a ARP request, the opcode, the operation code would be 1. And if it is a ARP reply, the operation code would be 2. That's it. Other than that, sender, MAC address, sender IP address, destination MAC address, destination IP address. Got it? Any doubt?
Sachin, in the packet capture, could you just switch the screen to packet capture? So that hardware type, what's that bracket 1 in Ethernet?
Value.
What that signifies, that 1? What does it signifies?
Signify means?
It's like there will be a meaning for it.
Yes,
right?
first field.
Okay.
Yeah.
Thank you, Sachin.
Anybody has any query on these fields? Just let me know. Everybody is clear about it. Yes, no, maybe.
Yes, Sachin.
Yes.
Sachin.
Sachin, one doubt, Sachin. So how will you? Please don't erase, Sachin. Just copying it down.
Anybody is asking something?
Yes, Sachin, got me. Sachin, how will the ARP request between router to router take place, Sachin? We are giving the ARP request from PC1 to network and PC1 to another network. The ARP request goes to switch and broadcast, and then goes to router. And then how the ARP protocol takes place between the this router and the another router. Can you please explain it?
Right. So on Friday, I believe I have explained to all. Let's say the PC is there, right? If the router comes into the picture, okay, in the network, if you have router comes into the picture, then we must say that something is, communication going on between two networks because router is involved. What I have told is router is involved when we want to communicate two networks, right? So now if I'm pinging my PC to other PC that is connected to other side, right? So ARP request will go at the first itself, it will do the AND operation. Okay, it will find it out that I need to send this ARP request to default gateway, right? Once it will go to default gateway, our ICMP request will get proceeded from PC to the router. Once it will get the default gateway's MAC address by ARP request and ARP reply. Between the routers, it depends. Between the routers, if we are using static routing, ARP resolution will take place then and there whenever we start the communication. But in case of dynamic routing protocols like OSPF or EIGRP, you will come to know about it. If dynamic routing protocol configuration has been set up between two routers, then at the time of establishing a neighborship, because there is something called neighborship established between the routers as soon as we configure dynamic routing protocols. So at the time of establishing the neighborship, it does the process of ARP. Okay. So even we are not doing any communication, but dynamic routing protocols be configured between the two routers in order to set up a communication between two networks. Then and there, while establishing the neighborship between these two routers, it does resolve the ARP. But if you are using a static routing, means manual routing, it will not establish any neighborship. So ARP request only will get resolved when we do the communication from one PC to the other PC. Getting it? This point.
Yes, Sachin.
Everybody please note it down and keep in mind this thing. How dynamic routing protocols resolves the ARP while configuring them and while establishing the neighborship, that we will see later when we learn about the routing. Okay, but just keep in mind that if static routing is used between the routers, static routing means manual routing. We are manually configuring some entries. Then neighborship process will not take place. So ARP request will not happen there. ARP resolution will not happen. Okay, so whenever we start the communication from one network PC to other PC network, then only between the routers ARP resolution takes place. But when the dynamic routing protocol is configured on two routers, they establish the neighborship, and while establishing the neighborship, ARP resolution itself takes place. So whenever we start communication in this kind of thing, between the routers, no ARP resolution will take place. Directly the ICMP request go from one router to other router. Everybody got it?
Yes, Sachin. In simple words, while statically configuring the routers, the ARP request, the ARP process never plays.
When we are configuring statically, the ARP request, ARP resolution only will take place between the routers when we start the communication between the two PCs or between the two networks.
Okay.
But when the dynamic routing protocol configuration has happened on the routers, there would be a process initiates like neighborship establishment of the two routers. Neighborship, if I'm saying, between two routers, there will be a process called a neighborship establishment. So that would trigger the ARP resolution. And ARP request and ARP reply both will take place then and that time only. So whenever we start communication in this case, ARP request will not take place between the routers. Only ICMP request will go from one router to the other router. I believe still people are in confusion. Okay. Can you see the whiteboard?
Yes, Sachin.
Yes, Sachin.
Now, what I'm saying is, now the PC1 and PC2 are in different networks. Okay. Between this network and this network. Okay. Now, if PC1 wants to talk to PC2, okay, obviously it has to talk over the network, different network, right? So if different network communication is there, we need to configure something in these routers so that these networks can communicate to each other. Okay. If I'm saying something need to configure, I'm referring something as routing. Okay. Let's say I'm statically configuring routing between the R1 and R2 so that R1 can recognize this network and R2 can recognize this network. Okay, I'm statically configuring static entry. Just 1 minute, I'm getting a call from Shobha. 1 minute. Well, I'm back. Can you hear me?
Yes, Sachin.
Okay.
Yeah.
Right. So this network and this network are different networks, right? So in order to communicate this network to this network, this network to this network, how do we do that? We need to do something on the routers because routing can be enabled on the routers. Okay. So if we are enabling routing means if we are configuring routing statically means we have a small network, we can do static, right? We can do dynamic, no problem. Now, statically, if we are enabling the routing, there would be no neighborship establishment. No neighborship establishment will take place. Okay. So whenever we start communication from PC1 to PC2, okay, then only our ARP resolution will take place between these two routers. Got it? Next comes to here. Let's say the same between the same routers, I enable dynamic routing. Dynamic routing means some routing protocol which can dynamically find the path. Let's say OSPF or RAIL or EIGRC. I done that. Okay. So what happens here? As soon as we configure it, the neighborship establishment will take place. Neighborship establishment will take place. And during neighborship establishment, ARP resolution takes place between the routers. Okay. Now, ARP resolution already happened between the routers. We have not done any communication here. Now, when the communication happened from PC1 to PC2, it does resolve the ARP of default gateway, right? But from router to router, there would be no ARP resolution take place this time, right? Because it's already happened during the neighborship establishment. So ICMP request from this router to this router will go directly without any ARP resolution. Everybody got it or still any doubt?
Got it, Sachin.
Yes, it's clear now.
Okay, fine. So this part we have seen. This part we have seen because I have enabled a static. We have not read about anything about dynamic at the moment. Even we have not read anything about the static. I will go through in the routing part. But just on a high level, I have given you this picture. I will show you this one also. How ARP resolution takes place at the same time when the routing takes place, when configuration of the routing takes place, right? So clearly you need to know this segregation, guys, because interviewer can ask you these things. When ARP resolution between the router takes place and when not, and why. Reason, now you know very well. Okay. You have not noted down. Please don't keep in your mind that you can remember everything. Please note it down, everything in your own words. Any problem, any query, just let me know. Everybody noted down?
Just wait a minute.
Hello?
Sachin, give us 1 minute.
Yeah, no problem. Take your time. Everybody done?
Sachin, I have a doubt, Sachin.
Yeah.
When we try to ping PC1 to PC2, let's come to the AND operation. Once the AND operation is getting over, when it finds the two PCs are in different network, then it will throw the ARP request to R1, right? I mean default gateway, right?
Yes.
Okay. After that, can you explain it, Sachin?
See, listen to me. The thing is that every part or every step in networking, be it ARP, be it ICMP, be it routing, be it IPsec, anything, right? Just try to relate the things. If I'm saying relate the things, just take it the first step. Why it happened? Okay. Due to that step only, the next step happened. If you know like how to relate each and everything, you will be able to understand the concept. Let's say here what happens. Okay, here what happens is PC1 try to ping PC2. Of course, they are in different networks, right? Router is involved here. Let's say PC1 is 192.168.1.50, okay, /24. PC2, let's say 172.16.1.100/22, something like that. Now, PC1 when try to ping PC2, definitely ICMP request generated. And ICMP need layer 2, layer 3 information both. Okay. Layer 3 information it has. This one, this one. Layer 2 information it need to have. If it doesn't have, they need to take the help of ARP. And ARP whenever triggered, right, then ARP need to do something in order to understand where does it need to send the request to resolve the MAC. Okay. For this, it will do the AND operation. Why it will do the AND operation? Because it need to know where it need to send the ARP request, in the local network or outside the network. So it will do the AND operation. Right? If there is reason, everything, whatever happening. So AND operation, how it will take place? 192.168.1.50. If the PC1 is initiating the ping request, then AND operation will take place 192.168.1.50 with /24 and 172.16.1.100 with /24. If the result comes out to be the same network, that is locally ARP request will go. If the result comes out to be a different network, ARP request will automatically analyze that it needs to send it to the where default. Correct?
Yes, Sachin.
Yes, Sachin.
Okay. Now, when PC1 is sending the ARP request, right? In this ARP request, it will encapsulate it in Ethernet header because it need to send over the network. It need to follow some rules. As per OSI, it cannot send ARP request directly onto the network. How can they realize it? Switch router cannot. I mean, they do not know ARP request. What is ARP request? They don't know. So in the format they need to send it. That's the reason ARP request, they just envelop it or encapsulate it in the Ethernet header, send it to the switch. And that Ethernet header has a broadcast address. Switch checks the header's checksum first thing. Then only it will decapsulate it, open the ARP request, and we'll see it. Okay. Now note down the MAC address of PC1. Okay. Now it's work done. Next work is putting the ARP request again into the Ethernet header and broadcast it to everyone. Whoever connected to this switch, broadcasting everyone. Okay. Everyone will discard it. Only router will accept it. After checking the checksum, open it, decapsulate it, destination IP, it will found it as a default gateway. Then it will process it. Process it means it will create the ARP reply packet, putting source MAC of this interface, destination MAC of PC1, source IP of this one, destination IP of PC1. It will go to the switch. Switch will again open it and note down the MAC address of the default gateway and in the MAC table. Now switch has both PC1 and this interface MAC address. Okay. Now it will go to the PC1. Now PC1 now know the MAC address of default gateway, right? So by this time, what happens is this ICMP request that was generated, that was on hold, actually it gets expired. Okay. So new ICMP request will generate and it will go to the R1. Now, whenever we ping for the first time, we'll get 80% success. This is the reason behind this. In a fresh new network, whenever we try to ping, we'll get 80% success. Sometimes also it's 60% success. Reason behind this is it takes time to resolve the ARP. Okay. So ICMP, ICMP request will come here. What ICMP request will contain? ICMP request always contains the source IP and destination IP of the original source and original destination. Means PC1 and PC2. So R1 will see that the PC2 PC2 IP address is 172.16.1.100. There is some routing table in the router. It will see the routing table from where I am learning this network. This router will see from where I am learning this network inside the routing table. Okay. In the routing table, it will see I am learning this network from this interface. Okay. So what it will do is the next hop is this one, right? Before sending the ICMP request, it has to know the MAC address of this one because ICMP need layer 2, layer 3 information both. So it will generate the ARP request. ARP request will go here. It will send a reply. It will get the MAC address of this one. Then ICMP request will proceed to here. Now when it will come here, again R2 will check what is the destination IP in the ICMP. This one. In the routing table, it will see from where I'm learning this IP, from this interface. Correct? Then,
yes,
then ICMP will go on hold and ARP request, this router's interface will generate ARP request. And every time, whenever I'm saying, I'm not every time telling you like ARP request need to be encapsulated in an Ethernet header, but whenever it goes in the network, it should be encapsulated in an Ethernet header. Okay, I'm not mentioning every time, but do consider this always. So ARP request it will create, it will go to the switch, again same process. Switch will note down the MAC address, it will forward it will broadcast everyone, it will accept it, others will discard it. When PC2 gets, PC2 will send the ARP reply, goes to the switch. Switch will also note down the MAC address of PC2 and I will send it to here. As soon as it gets this ICMP request will get to here. I mean through switch. Okay. This already we have discussed and I have already explained you this, right? Time to time will, because this is very important in every technology, whatever we are going to learn, security, routing, OSPF, RAID, PIG, RP, everything does involve this one. Okay. Just give me 1 minute. Do you understand this?
Yes, sir. Yes, sir.
Just give me. All right, guys. So, is there any query on this?
No, Sachin.
Then next time, if I would ask the questions, would you be able to respond?
Yes, Sachin.
Yes, Sachin.
Sachin, once the ICMP request reaches the PC2, then what we need to explain about that?
When ICMP request reaches to PC2, what we need to explain?
From there, what we need to explain about that?
Explain. Not able to understand the question.
Actually, we are trying to ping PC1 to PC2, right? So for that only the ICMP was initially generating. So once after this all process, it will finally reaches to PC2. So from that.
Yeah, once the ICMP request reaches to PC2, PC2 will open it, right? And this ICMP request again, I would tell you, these requests need to go onto the network with a certain format or within encapsulated in a certain header. So this ICMP, where it need to be encapsulated?
Ethernet header.
Ethernet frame.
This ICMP is a network layer protocol. So where it need to be encapsulated?
Layer 3 network.
IT header, right? Like layer 2 is what? Ethernet header. Layer 3 is what? IP header.
IP header.
Right? So ICMP request is again, I think I forgot to tell you, ICMP request is again need to be every time whenever it go from one device to other device means it need to follow the rules. So it need to be encapsulated in an IP header, then it will go. Right? Okay, so when this ICMP request comes to PC2, right, what PC2 will do? PC2 will open this ICMP request. He will see this ICMP request destination IP of its own, right? 172.16.1.100. So what it will do? It will send the ICMP reply. Right? Okay. And ICMP request will go to from PC2 to switch to router to another router, then switch, then PC. Right?
Yes, sir.
Does it need to resolve anything this time?
No, it's a unicast, right?
It's a unicast.
Yeah, got it.
See, the ICMP request is unicast before also, and ICMP request is unicast now also. ICMP request is not a broadcast because source IP, destination IP, and source MAC and destination MAC, it cannot be broadcasted. Our destination IP is not changing anything. Okay, we know it, and ICMP request, we know where we want to reach. Okay, so that is again, ICMP request is always unicast. Started from PC1 till PC2 and PC2 till PC1, it will always be unicast, never be a broadcast. Right? Why ICMP request is always unicast? it does know it where it has to reach, because it's gonna get all the information from the ARP. That is the reason ARP is a broadcast, ARP request, right? So ICMP is getting every information from ARP. So why ICMP need to be a broadcast? ICMP is always unicast. It is getting all the information from ARP. Getting it?
Yes, Sachin. Yes, Sachin.
See, we'll come back. I mean, these things, right? We'll come back again and again while doing our labs. We'll see these things again and again. Okay, so that it will be in your mind forever. So doing everything does involve these basic things always, any technology, and we'll see it. Okay. So what we have discussed about, ARP packet, what all the fields are in the ARP packet. Okay, and again we have analyzed, right, when the ARP request gets generated between these two routers and when not. Okay, difference you can clearly know by this. This lab will do at the time of routing. Okay. Can you see the command prompt?
Yes, Sachin.
See, I am pinging ping www.one. That is anything which I cannot reach. Okay, let me try any IP 146.1.1.2. Anything. Okay. So whenever we initiate a ping command, right? Why do we initiate? In order to check the reachability. Reachability means the other device which I am trying to ping is reachable from my device or from my PC or not. Correct? So while checking this reachability, right, either we can get a success or we have lost the packets like this, request timed out. Okay. So the thing is that what we need to understand is the ICMP request and ICMP reply, we understood. Okay. But the thing is that we need to understand also, if there is no success of ping, what gonna happen? What all messages we can get? Okay. See, ping, if you are doing a ping, does involve an ICMP. Okay, ICMP is the Internet Control Message Protocol. Right? Now, if there is a success means ping is, means our device or network, whatever we are trying to ping is reachable. Okay, so in success, what will happen? Two things: ICMP request will go and will get the ICMP reply. Okay, let's say my device is not reachable, no success. What will happen? It should give you some message to tell you what is the problem in reaching to that particular device. Okay, I'm pinging some IP. Let's say my colleague's IP is 192.168.1.2. Okay, maybe I'm getting packet sent 4, received 4, okay, and 100% success, something like that, right? We need not to do anything, right? But if it is not a success, then we should get something that can point it out what exactly is the problem. Maybe we can get it, right? So if it is not success, maybe request timed out, that is RTO, Maybe it can be destination unreachable. Maybe it can be network unreachable. Maybe it can be host unreachable. Okay. So the thing is that these are the categories. This one, this complete thing, we can call it as the ICMP messages. Okay. It depends which message we are getting, whether it is a request, whether it is a reply. In case of success, not success, maybe request timed out, maybe destination unreachable, maybe network unreachable, maybe host unreachable. Okay, I'm just giving you to explain this. Okay, but what are the error messages that will actually come up that I'm just going to give you? Don't write. Any questions till there? If you understand this, we will go further. Yeah.
Sachin, can you explain the success and not success again? I didn't get it.
Just 1 minute. Yeah, what was the question? Sorry, please tell me.
Yeah, can you explain that success and not success again? I didn't get it.
Okay, no problem.
Yeah.
Can you see the command? This one is the command prompt, right?
Yes.
I'm pinging. Why I'm pinging? First of all, I'm pinging to check the reachability of anything, be it any website, be it any computer network, be it any switch, be it any router, be it any firewall, anything. Whenever we try to check the reachability, we need to use the ping command. Okay. So let's say I'm trying to ping google.com. So either by the IP or the domain name, we can ping. I'm getting reply, right? Reply. Okay. What is this? I have sent 4 packets, 1, 2, 3, 4, and received 4 from Google. Lost 0. Okay. That means our communication is a success, right? That's what I'm talking about this one. Okay. It does involve 2 things. ICMP request and ICMP reply. We have sent the request, we are getting the reply. Getting it? But let's say I'm pinging this one. Any IP is this, let's say this is my switch IP in my network. Okay. So, and I'm pinging. This is a random IP. Okay. I'm just taking it as assumption. I'm just trying to show you what, if we are not getting success, what else we can get. So I'm getting request timed out. Correct?
Yes.
This is one of the error messages, right?
Sachin,
So,
I have a doubt.
Okay.
Does the ping www.google.com works without having internet connection?
Without having internet, I don't think so. If it is in your cache, then it may work.
What, Sachin?
Tell me.
I didn't understand.
Okay. Your question is, if you don't connect it to internet, will ping to google.com work or not? Correct?
Yes, Sachin.
No, it will not work. but let's say it is saved in your cache, right? There is a DNS cache, there is a ARP cache, there is a IP cache on every computer. Okay, then it may work sometimes, but most of the times it won't work. Okay, so let us not get into that at this point of time. Okay, first understand whatever we are going through at the moment. Right? Slowly you can pick up those things. You will be able to understand.
Okay, Sachin.
So, right. So there are two examples. One is www.google.com, anything, google.com, csscorp.com, my facebook.com, yahoo.com, whatever. We are getting success, means ICMP request goes and we are getting ICMP reply. But let's say I'm sending google.com, I'm sending csscorp.com, I'm sending anything. I'm getting some error. Error means it is telling me request timed out. Sometimes it is telling me destination unreachable. Sometimes it's telling me network unreachable, host unreachable. So the thing is that these type of error messages also come, right? So these are the category of messages, ICMP messages that we need to understand, right? So let us come to our point. There are two categories of ICMP messages. Query message and error reporting messages. Okay. If I'm saying query message means ICMP request and ICMP reply comes into the query message. Okay. ICMP request and ICMP reply comes under the query message. Error reporting messages means when we don't have a success, right? So we need to understand what kind of these error reporting messages are there. Okay, there are 5 types of error reporting messages are there. First is destination unreachable. Second is source quench. Third is time exceeded. Fourth is parameter problem. And fifth is redirection. Okay. Okay. Now these are the messages like query message. Under the query message category, we have ICMP request and ICMP reply, means success. Okay. Now this ICMP request was also called as, whenever you see the packet captures, you will get to know it is called as a echo request and will get the echo reply. Okay. ICMP request can be called as an echo request. ICMP reply can be called as an echo reply. Now, whenever you see the packet captures, right, there are certain types of type means which type number does it belong to. Okay. So echo request always represented with 8. Echo reply always comes with 0. Right? Destination unreachable has a type of 3. Source quench has a type of 4. Time exceeded has a type of 11. Parameter problem is a type of 12. And redirection is a type of 5. Okay. Now, see, these two things, okay, ICMP request and ICMP reply, very important. Need to remember and keep in mind the type. Other than that, you need to keep this also in mind. Destination unreachable, that is the type number 3. Okay. Rest are source quench, time exceeded, parameter problem, redirection. Okay, you can keep in mind. Good enough. Not, no problem. Right? Can you please note it down? Or else if you don't note it down, that is not a problem. I'll share the document. Okay. Any questions here? Till now, clear or not?
Sachin, what is that second point of the source?
Source quench. Quench
what
is
is-
QUENCH.
Yes, yes. What is that? What is that source quench?
I'll tell you. I'll
Fine.
tell you about all messages. Okay. But just understand what are the category of query message and what is the category of error reporting messages. Right. So why we are learning this? There should be some reason behind this. Okay. Do you agree on it? If we are learning something, there should be some reason behind it. What can be the reason? Do you think about it? Why do we need to know this?
If a customer asks whether the message is packet is pinging or not, we have to
Maybe
check
for
whether
immediate recognition with the number type itself, we can find out immediately what the error
we
is.
can know that there is
See,
a mismatch.
Yeah. See, whenever we try to ping it, okay, either it's a success or no success. If it is no success, then it is a category of error reporting messages, right? If you know about error reporting messages, when which message comes, let's say destination unreachable. If you are not familiar, we will go and try searching the Google. That is one of the things. That's fine, no problem. But let's say you're troubleshooting with a customer, okay, and you ask him, please ping this one, and he pinged it and getting the message of destination unreachable. Okay, if you know it, you can easily educate the customer. Maybe customer would ask you, what is this destination unreachable all about? I never got this. So you can educate the customer, this is the reason you are getting destination unreachable. But if you are not pretty familiar about it, then you will keep searching the Google. Let me search the Google and answer it. Sometimes it looks fine. Sometimes customer will come to know he himself don't know, and he is troubleshooting the things. Okay. So that is not a problem. But the thing is that in order to understand, like if my ping is not success, and which type of message is coming and what is the reason behind it, we'll definitely be able to troubleshoot it more efficiently. Correct? But if we don't know error reporting messages is coming, means not success, but we don't know what is the reason behind it. Is there any way we can resolve it? We'll keep searching the Google. We'll not be able to resolve it. Right? That is one of the things that we can do. Okay. This is the reason you know this. Now let's say you are working on customer issue. Okay. You are trying to ping for your in between your troubleshooting. You thought, okay, let me see if I'm able to ping the router, if I'm able to ping the switch or not. And you are not able to ping, and you are getting out of these messages. Okay, and you know about it because you have already learned about it. It will make more efficient your troubleshooting. Okay, you'll get to the resolution, you'll get to the conclusion pretty fast. Right? Agree with it?
Yes, Sachin.
So, now timestamp, sorry, these query messages, right? In these query messages, I just missed to include one more messages is there. Okay, the query messages is like if request is going, we are getting the reply for sure. These are query messages. Okay, so one more query message is timestamp request and reply. Timestamp reply. Okay, I will explain you all the things, but just note it down. In query message category, there are two types of messages. echo request and echo reply, and timestamp request and timestamp reply. Okay. In error reporting message category, we have 5: destination unreachable, source quench, time exceeded, parameter problem, and redirection. What are the type? Why do we need to know these types? Right? These types, whenever we see the Wireshark, okay, in the Wireshark, these error messages, if showing up, they will show up with their types. Okay. Got it?
Yes, Sachin.
Okay. Now, I will explain you each and every message, and then we will go to Wireshark to verify each and everything. Right? Guys, have you noted down?
Yeah, Sachin.
Yes. Yeah, give me 5 minutes, guys. So, coming back. Okay. Anybody is there whose attendance is not up to Friday attendance? Okay. So only Alima. Other than Alima, everyone's attendance has been approved.
Yes, sir.
Yes, Sachin.
Yes, sir.
Okay.
Yes, Sachin.
So me tell So let me share my screen. All right. Next thing, what we need to know is till now, what we know about the ping that uses ICMP protocol is a layer 3 protocol, and ICMP is used to check the reachability of the destination, be it a website, be it a device IP, whatever it is. To check the reachability, whether the other, whether the destination is reachable or not, right? Now, after knowing this, do your ICMP definition, whenever anybody asks you, does it get changed? Or maybe some additional thing that you can tell about ICMP now? Yes, no, maybe.
Can say which type it is.
Which?
Type.
No. I'm not saying type. What I'm saying is, anybody asks you what is ICMP? Okay, what is ICMP is, you can say Internet Control Message Protocol, right? Why it is called Internet Control Message Protocol? Now we know what is the importance of that message in this full form, Internet Control Message Protocol. Okay, so earlier, when we don't know about this thing, whatever is in front of the screen now, we used to define the ICMP as a protocol which can check the reachability of the destination, whether the destination is reachable or not. Okay. Now, additionally, we can say ICMP is a request which can check the reachability of the destination or not, and also it can tell us about the errors which we can get in order to reach to the destination, right? Because in front of our screen now we know about that these all are messages, right? So not only checking the reachability, it also let us know about the error reporting messages, by which we will come to know what exactly the problem is. Correct?
Please repeat it. Could you please repeat it?
Yeah, what I'm saying is, earlier, what we knew about the ICMP is a protocol which is used by ping, and that is used to check the reachability of the destination, right? Destination, if I'm saying, be it a website, be it a network device, be it your colleague's computer, anything. Now, additionally, what we can say after knowing this, that ICMP is a protocol which can check the reachability of the destination, and also it can give us the information about the errors in reachability to the destination. Okay. Also, the thing is that if it is reachable, that's fine. If it is not reachable, then these messages will come, right? So it also tells us about the error messages that can come into play if my destination is not reachable, right? Then interviewer can ask you, what are those messages? You can define these messages are two types. First is the query message. Other one is the error reporting messages. Query messages that always occurs in pairs. There is a request, then there should be a reply. So first query message is ICMP request, that is equal request, ICMP reply, that is equal reply. Second is timestamp request and timestamp reply. Right? Second category is the error reporting messages, in which 5 categories are there: destination unreachable, source quench, time exceeded, parameter problem, and deletion. We'll go one by one. Got it?
Okay.
How this ICMP, you can say ICMP packet format, you can say ICMP header, whatever you want, you can say. Okay. So what does it contain? So I'm talking about ICMP packet format, or else you can also say ICMP header. So first field is type. Okay. Now, guys, in the starting, I told you it come with, you will be able to learn, different headers. You come across different headers: ICMP header, ARP header, IP header, TCP header, DSCP header. Right? So my suggestion is how to remember it is in the fields. Whatever the fields in the header, you should know about it. Right? If anything asks you about describing the header, right? You just prominent fields you need to know about. Or else you can, if you really want to remember or keep in mind, what you can do is, the best one is, in a chart, you can just have all the headers, okay, and paste it on your wall, wherever you study, right, till the time your training completes. So that every day when you wake up, you can see those headers and you can recall about the fields. It will help. Okay. So type, second field is code, third field is checksum. This field is called as rest of the header. There's nothing field called rest of the header. I'll tell you why I'm writing it. This is data section. Okay. When I say type, what does it mean? Type means these are the types. Okay, what I'm talking about. If it is a ICMP request, type is 8. ICMP reply, the type is 0. Destination unreachable, type is 3. For this type, right? This is the type field. What type of message it is? Okay. Code. Code is actually, what does it mean? What is the reason we are getting this message? Okay. There are certain types of code. Certain types of code. Let's say my type is 3. Okay. My type is 3. That means what?
Destination unreachable.
Correct. So if my type is 3, that means destination unreachable. But what is the reason behind it that destination unreachable? Okay. So those reasons are the code. These are the reasons behind the error message. I'll tell you about the code. One minute. Okay. Checksum is same. Whatever we have understood till now about any header and checksum. Checksum is to check the integrity of the data. Okay. So this field, the first three fields, this field, and this field. These three fields common for all messages. So whenever my message goes, there should be some ICMP packet format or ICMP header. Okay. These three fields common for all: type, code, and checksum. The middle section is the rest of the header. Okay. This rest of the header, this middle field only can be changed, or I would say will be changed depends on the particular message. Okay. Last field is a data section. Okay. Data section actually tells us about whatever the error is. Okay. Data section tells us about the error. Got it? Any doubt?
Sachin, you said data section tells us about the error, right? Is it like a detailed reason? That is what you mean? Or?
Data section, right?
Yeah, you said data section. It tells us the about the error, right?
Correct.
So is that like a detailed like description or something like that, or does that just come under code?
The detailed error, not the code. Actually, code tells us about the reason, right? But the thing is that we know the type. But what is the error actually? That will come in the data section, like destination unreachable or source quench or time exceeded. Right? Just a minute, okay? Let me take a call. Hello. Yeah. हाँ? कौन बोल रहा है? कौन बोल रहा है? Sorry. Yeah, Ben, tell me. Yeah. Guys, can you hear me?
Yeah, Sachin.
Yes,
Yes,
Sachin.
Sachin.
Yeah, Ben, you were
Yeah,
asking some question.
yeah, Sachin. No, I'm just asking this data section, right? You said it tells us about the error, but
Correct.
then in the same way you said I mean, it's given their code, you give the reason behind the error message. So isn't it the same thing or?
No, code is the reason, right? But what exactly the error is, right? See,
Okay,
let's
so
say the error
why
is
it happened, and then what happened? Is it?
what happened, correct? See,
Okay.
this type is this one, right? The number that Wireshark, by Wireshark we can understand. Okay, type 8, this is the ICMP request. 0 reply, 3 is unreachable, right? But what exactly is the error message that comes in the data section? Why it is coming up, what is the reason behind it, this code value actually indicates. So what all code values are there that I'm going to tell you, right?
Okay, Sachin.
Any other questions on this? To understand this simple format of ICMP. The thing is that the middle part, that is rest of the header section, right? The rest of the header, that would change depending upon the message type. Let's say it is destination unreachable, then it would change in that way, right? Let's say it is source quench, then the middle part would get changed. How it will get changed, that I will tell. But you should understand this minimum thing in the IP packet, ICMP packet format. Got it? Everybody got it?
Yes, Sachin.
Yes, Sachin.
Yeah, Sachin.
I feel you guys are hungry now. No? Okay, so IT guy is about to join at 2 p.m. I don't know where he is. Um, Let us wait for some time. Then I will go for a lunch. So in the meantime, I will cover the some part of this stuff. So as I have told you, this is the most prominent, and most of the times we get this type of error. If it is a success, okay, this is fine, right? But most of the times we'll get destination unreachable kind of things, right? Why? Let us see the destination unreachable. Can I claim this?
Yes, yes.
Yeah, Sachin.
So let us see the first message. That is very important. Destination unreachable. Okay. So what all fields will be common? So we are going to see destination unreachable in the ICMP packet format. So what all three fields will be common?
Type, code, and
Code
checksum.
and checksum. Type, code, and checksum. This middle section will come as unused. Okay, means all zeros will come here in this. It is a format of destination unreachable. Okay, and this one is the data section. Whatever my data is there. Okay. Now, what the type will come? Type value in case of this destination unreachable, type value come as 3. Okay. And I told you about the code field. Okay. Code field is telling about the reason behind throwing the message of destination unreachable. Okay. So why I'm saying it is very important, because there could be code value can be 0 to 15. Right? Means there could be 15 reasons behind this. I'll tell you, like the code 0 means network unreachable. If the code 1 means host unreachable. Code 2 means protocol unreachable. Code 4 is port is unreachable. It becomes low or writing on the whiteboard. Okay. Okay. So in the same way, we're gonna get up to till code 15. Okay. What I'm saying is, you just need to know this. There are codes 0 to 15, right? If you know these 4 things, that is enough. Okay. Even if you don't know code 5, code 6, code 7, code 8, code 9, 10, 11, 12, 13, 14, 15, hardly matters. You can search on the Google because they are not very common. Okay. These are the common ones. But we should know for the destination unreachable, there could be 15 reasons. And that's the reason there are 15 code numbers. 0 represents network unreachable, 1 represents host unreachable, 2 represents protocol unreachable, and 4 represents port is unreachable. Okay. What does it mean? When we say code unreachable, okay, what does it mean? It means that the destination you are trying to reach could be one minute. Yeah. Saban. No, actually, a bridge is already open, right? That's the one. Wait, guys.